You understand my pain, don't you, Rosie? Not many would. Something terrible has happened to the coil.
It was all going so well. My plan to build the ultimate handheld Tesla coil was going okay. I built this lovely yellow half donut primary coil. Quite unusual. I 3D printed an even lovelier coppery secondary and created an unlovely gluey mess.
Never in my wildest dreams did I think it was going to look this bad.
But it cleaned up all right, and it's only temporary. To test it out, I replicable this schematic from lab coats.
So here's the staccato interrupter part,
which enabled me to use a little trick
matched with the upslope of the AC signal.
By using the mains. What could go wrong?
Nice.
Well, nothing as it happens, and it worked
What a result.
very well. But I needed more power. In the last episode, we created the heart of sparkness, hewn from raw PCB, dissolved in acid, and soldered delicately together. The heart of sparkness. It's a full bridge of IGBTs that doubles the voltage going into the coil, increases the sparks, and causes some small resistor fires. This is fine.
That's a resistor. That is a resistor making that flash.
So this was the exciting conclusion of the last video. But unfortunately, since then,
something terrible has happened to the coil, and I've got to tell you about it. So, you remember we'd had quite a successful last video, and I got to thinking about that resistor that kept burning up every time I was trying to run the coil for more than a few minutes. I replaced the resistor with a slightly larger one. Ooh, that's a big chunky boy. And sure enough, it did work for as long as I wanted it to at that point. I was playing around with it, kept turning the power up. I was laughing away, A little bit more, bigger sparks, more power. Ow. Yay, oh, so much fun. And then, crack, bang, fizzle. Spark shot from the primary into the secondary, racing up the coil, vaporising that gossamer thin copper. And with it, hours of work, years of dreams, laughter turned to tears. Hubris came a-knocking. Hello, mate. It's your Uncle Dave here. Poor little coil. He blew his wires off, didn't he? As far as I can see, we've only got one choice, which is obviously to wind another coil, which I don't really want to do, but it's going to happen. So I might as well take the opportunity to improve it somewhat, because there was a problem caused. This piece, this ridge here, caused a real pain, because when I was putting my finger on it, I couldn't get the wire to neatly pile up in that direction. So I'm going to eliminate this step. Usually, when I'm printing, I would be using the AMS, the automatic material system here, and it sort of feeds through and goes over here. But in this instance, I'm going to be using polycarbonate carbon fibre, which doesn't work in the AMS. I really like the finish. It's very nice looking. So that's going in now. So now just attach the pipe. I'm going to press send on the software, and then there is a slight delay, because would you believe, between going from over there to over there, it goes via China, which I think is sort of that way. Clearly some sort of data gathering going on for those guys. China's welcome to this design. I'm going to share it with you all anyway. Right, it's sending through the cloud service, so it's very slowly heading in this direction via China. There it is there. Very exciting. Now, pop you on a little stand. time for me to explain why my control system is going to vary a little bit from other people's. So I'm going to use a phase shifted control, which uses the full bridge that we built in the last episode, the Heart of Sparkness. And it needs to use a full bridge because it needs to have those 4 switches in order to pull off a little trick. I mean, there's not really going to be very many simple ways to explain this to you. What's a good way? So
Yes, it's a whiteboard, I'm afraid. A sort of ultra-low refresh rate monitor that you have to fill in yourself. At least it's colour. 4 switches between the 300 volts and the 0 volts. So how does the Heart of Sparkness work? It's basically a full bridge inverter. What's inverting? Well, this voltage, which at the moment is a DC voltage that's not going up and down. The purpose of this is to turn this DC voltage into an AC voltage, which goes into the primary coil of the Tesla coil. At the moment, I'm only sending 2 signals to this. So when I send one signal, these 2 switches close, and when I send another signal, these 2 switches close. So what effect does that have? 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 You see, you probably already can see. This one's closed, so down there, crawl and go down. So what voltage is that going to be seeing? It's going to be seeing 0 on that side, 300 on that side, the top of our wave. But then what happens next when we switch the switches that are switching? Well, through this way, this end of the coil, instead of being connected to 300, it's connected to 0. And this end of the coil, instead of being connected to 0, is connected to 300. So that's minus 300. And this is plus 300. You just keep flipping that arrangement around. You get
let me just close the printer door, so it's quite noisy. So you know the way that a full bridge works? 4 switches. These 2 switch on, and then these 2 switch on, and then these 2 switch on, and then these 2 switch on. But we can build a system which deliberately doesn't quite do that. So the phase of those 2 switches go out. And that means that you can actually vary the sort of pulse width that's on each side of the 0 crossing line.
this has the same effect as ramping the voltage up or down, depending on what we want to do, over an arbitrary amount of time. And that hopefully is what's going to produce really nice straight sparks, because this is going to be a handheld Tesla coil. We want the sparks to sort of shoot out like a bullet from a gun. Not a gun. Can we mention guns? I don't think we are. Are we allowed to mention guns?
Usually to do this complex switching arrangement, people use a thing called a complex programmable logic device. I thought, wouldn't it be more fun to go further back in time and use the original logic gates?
Logic gates, yes. I've heard of those. What are they? Well, our story starts back in 1705. I'll skip to the end. Everyone says computers work by zeros and ones. Well, these are the zeros and ones. To us, that's going to mean a 0 is actually 0 volts and a 1 is 5 volts. And these circuits flow pulses of 0 or 5 volts through them. Transistor logic, TTL, logic family. Here's my special book about them. It's fascinating. Texas Instruments started the 74 series integrated circuits, which are, well, they look like this. This is the kind of chip we're going to be using. Right, so this is the top of one of these chips that's been etched out. Isn't that beautiful? So this is the silicon chip itself, and these are the wires that go off to the legs of the chip. This is a quad NAND gate. So there are 4. You can see there's 4 repetitions of the structure there. So this is a NAND gate, that's a NAND gate, that's a NAND gate. And here we are. This is the original 1966 groovy baby schematic. This is why it's called transistor to transistor logic, because it's just transistors. So there's your two inputs and there's your output. Depending what the state of these two is, gives either a 1 or a 0 out. These have been etched onto a piece of silicon. Even back in 1966 they were starting to do this kind of crazy stuff. This is an integrated circuit you may have heard of. This is a bit of silicon I have on my shelf. Isn't it sparkly? They discovered that you could make thin slices of this and etch them and deposit things onto them, and you could actually make these circuits. So this is an individual transistor here. So there's lots of different types, not just NAND, and you can connect these together, and you could actually build an entire computer just using these things. In fact, I think I'm right in saying that the original Pong, you know Pong, bunk, 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 was built. You could build that entirely, or was built entirely out of these type of chips. Let's see if we can find any pickies. Oh, there we go. Nice. So yeah, this is Pong, and you can see it's just made out of these TTL logic chips, and probably all 74 series. Can we do a zoom? Yeah, 7493 there. Just trying to read these sideways. It shows you that you can make something quite complex. There's the one we just looked at. That's the 7400. So yeah, that's the game Pong. It's not running any software. It's just running on these logic chips on a board. So I want to use this level of technology to build the control to control the pulse widths that control the phase of the heart of sparkness. And why would you do it like this? You wouldn't. I'm just doing it like this because I want to. Let's look at this again. That is so pretty, isn't it? What an image. It's like it's glowing with gold. That is gold, by the way. Gold and silicon. That's where we are. Cities of gold, but tiny.
'74 series logic. That's what we're going to do. My plan is to build the control system using as much as possible, if not entirely, 74 series logic chips. Those guys. Whoop.
Hang on a second, what am I building? Well, that's a very good question. I have come up with a schematic to create this kind of variable pulse width on the heart of sparkness. There's the heart of sparkness. You can see I'm still using MOSFETs, so this is quite an old design now, because we've moved on to IGBTs. This was the 13B version of this. I've been around the houses a bit. This is LT Spice, by the way. This is analog circuitry simulation software. I had to install some extra plugins and stuff to get it to work with the logic chips. You can see they're all represented by logic gates. It was actually quite hard to do that, so if anyone knows any software that just does it off the bat and you don't have to do any changes to it, recommend it down below, because I'd be interested in knowing that myself. When I run the simulation by pressing this green button up here, then it refuses to play ball because apparently a couple of the components have fallen out of the library. That's okay, that's okay, that's okay, that's okay. In the middle of the heart of sparkness, of course, is the primary coil there. So if we put a probe on there, there we go. We can see the ringing up behaviour we're looking for. Ignore all these numbers around here. It's just to show you that it exhibits the behaviour. Because this is set up like a dual resonant coil, you're getting this resonant build-up, so we can't actually see the variable pulse widths that I'm trying to create. So if we stop the simulation, delete the capacitor, put in a straight wire. There we are. I'll start the simulation again. Okay. Now I'm going to put mark a reference on one side of the primary coil and probe on the other side. See that? No. Sorry, it's blue. I change the colour? Yes. Pink. It's not dialed in. I just got it as far as working well enough. Anyway, you can see that the pulse widths on either side. So you can see there's 300 volts there, minus 300 volts there, like we were talking about earlier. And they are getting wider as we go along the pole. So this is hopefully like a long straight spark being formed. They are getting wider on each side of the 0, and then up here, the full power on the heart of sparkness right there. So this is roughly the behaviour we're looking for, and it's coming from this circuit that I designed. No time to go into what any of it does now. So yeah, that's what I'm up to with my fiddly fingers on these biddly breadboards.
So these are some AND gates, and this is the chip they're on. So you can see there are 4 AND gates on one chip. So I'm having to keep track of the wiring on both sides of each of these separate components and on which chip they're on at the same time. Look at these inverters, 6 of them on one chip. Things like the flip-flops, which you'd think, oh, there's only going to be 1 of them on the chip. No, there's 2. This is forcing me to think much harder than I enjoy to think. Well, it's coming along all right, but it's doing my head in, really, because I've been looking over here on Photoshop, colouring in a wire, and going over here, putting that wire in place. It's actually taken so long that this is finished. Oop. Fell off. I told you it didn't. See, it doesn't stick very well onto that engineering plate, just well enough. That looks nice, doesn't it? Yeah. So what I think I'm going to do is move this operation over to here, and now that we've got this, I'm going to restart the winding operation over here and maybe do everything simultaneously. So if I do a bit of winding, it might make me feel a little bit crazy. I'll cure that crazy by going over and doing this crazy to here, here, that crazy, this crazy, here, 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 crazy, here, here. And then when I feel crazy from that, I can go back to doing the winding. I think it's going to work out really well.
What gap? Oh yes, the gap between the last episode and this episode has been a very, very long gap indeed. Bit of a weird one. Went on holiday after making the last episode.
What are you doing, Uncle Dave? I'm climbing a mountain.
Which I really enjoyed doing, and I was loving all your comments and all the positivity and the fact that people were actually liking what I was doing. Climbed some mountains on holiday.
Oh man, look how high up those go.
Came back, went to work on the next video, and I was like, that's weird. I'm not really feeling it. I'm not really feeling my mojo's not flowing. My energy's not there. My chi is out of centre. Whatever words you need to describe that sort of feeling of just being on song, able to sort of get into a kind of flow state. Yeah, I wasn't there.
I think this isn't even along the ladder.
A little bit of background. I am diagnosed with ADHD. Big surprise, I know. Excitable fellow. Sometimes oversteps the mark. Diagnosed long time ago, medicated.
That means maximum of 3 people, I think.
When I work for other people, it's always little short jobs. Do a technical, complex thing, deliver to client, receive money, get the flip out of Dodge. So it didn't really occur to me that because everything else was going well, that not being able to make the video was an ADHD-related thing. But then recently I thought, maybe it was. So got an ADHD coach, stroke therapist, who's very good. And if you have ADHD, I do recommend that you find someone to talk to about it who actually understands it, because just because you've got it doesn't mean you understand it yourself. Do you know what I mean? Anyway, she said, no, it's because you're just afraid of having a task that doesn't have an end, because you have to keep making videos forever if you do this.
It seems to be getting longer and longer and verticaler, this ladder.
And so the fact that it was getting popular, and that's when you got scared.
So it's easy for the nerves to take hold now.
Yeah, scared. Apparently, I got subconsciously scared, and then that part of my mind stepped in to protect me and just put an invisible barrier there and just said, no, don't do this, because you're going to hurt yourself. So, we've been talking it through.
Still got miles to go.
negotiation with the old subconscious. It's a weird... It is tiring. It's a whole weird thing. But it does seem to be working, because here I am. Anyway, I know only about one of you actually cared where I'd gone, deeply enough to need this explanation.
I'm glad I've got you here to talk to me anyway.
Thank you everyone else for bearing with. I know that this wasn't of any interest. I think this was more for me than for you, if I'm honest. And I'm sorry about that. I'll never do anything for me ever again in a video. I promise.
2 people down there, plus me, is the 3 maximum that this ladder can take. It's older than me, this ladder. So, pretty ancient. 1972 this was put here, I think. I'm becoming an experienced ladderman now.
And now, a man with ADHD does some sanding.